So, hello everyone, good afternoon. My name is Peter and please welcome to my presentation about the software Wolfram Mathematica, which I will speak about for following 50 minutes maybe or something like that. So, let's get straight into it. Here is a quick overview of what my presentation will contain. Firstly, I will just briefly summarize what Wolfram Mathematica is about. Then I will, this is like the main message of the presentation. If you are working with Mathematica for the first time, what you should expect and what it will look like. I will also show some basic functionalities and operations and functions which Mathematica offers. It will certainly be just a small fraction of everything Mathematica can do, because that is a pretty large amount of things. There will be a chapter about advanced features, or like little bit advanced features. I might just skip that and leave it for further reference. If you ever find yourself interested in that, you can download that later on and look into it yourself. Maybe we will have enough time to go through that too. So, what is Mathematica? The best or one of the most interesting ways to answer this is to let Mathematica answer on its own, which I will do, right now. And hopefully you will see that it does something. What it actually, this is one of the features Mathematica offers, that it can interpret written language. It works in English, only in English I believe right now, but it can interpret written language and do something about it. For example, if you put in a question, it can give you an answer. So Mathematica thinks it is an all-in-one computation and visualization system, development environment and deployment engine used across diverse technical fields, including engineering, science, and financial analysis. I would just like to add that you can use it for basically anything where numbers are involved anyhow, and there are even like outside of the, math, there is lots of usage and interesting things you can do with Mathematica. It was created by Stephen Wolfram in 1988. It uses its own scripting language called Wolfram language, and like the main selling feature of Mathematica is symbolic calculation. For those of you who have some experience with programming, you know that most common programming languages, what do is they use some variables, but they always, at the end, the variables represent some numbers in the system, while here Mathematica actually like computes with or can do some operations with variables which do not have to carry any numerical meaning. I will show you later on what it means, but you will see it is very useful. I had to mention this short comic strip where they compare programming languages to weapons. So for example, the first one, which refers to C, like one of the most common and basic programming languages, is compared to a normal rifle. If you know something about Java, you know that one of the most famous mistakes you can do there is a null pointer exception, or one of the exceptions you can get there is null pointer exception, which most often breaks the whole program. So this is about the second picture, and the third one, this refers to Wolfram Mathematica, which, if you couldn't read it for any reason, says that Mathematica is a low orbit projectile cannon. It could do amazing things in only if anyone could actually afford one. So this speaks both about its strengths and its somewhat weakness, that Mathematica is extremely powerful for many types of computations. The thing is, it is quite expensive, so you can consider yourself quite lucky that if you won the license in the competition. So let's get to do next slide. So first, if you open Mathematica for the first time, what it will look like, it will be, I will just open one new programming environment called Notebook, and it will just, you can't see that actually, never mind, it will just be completely blank. Here I have added some background features and so on. But what is most important is that you can just write there right away and launch your or execute your commands. If you probably should try to save your file somewhere, you will notice that Mathematica uses its own format of files called NB for notebook. Compared to other programming languages, which are often executed from first line to the last line at once, you can execute Mathematica commands not exactly line by line, but cell by cell, where cell is a group of commands. You can put it into each cell either one command or multiple ones. And if I go with my cursor to the right side of the view, you will notice these frames at the very right end of the screen, where there is this structure of frames I'm trying to highlight now, and these are the smallest one are the cells. So for example, if I highlight this one, so this is one cell which corresponds to this big heading, while there is for example here another cell which corresponds to this text, and so on. And if the cell, which it does by default, if it contains a Mathematica command, like for example this one, you can just execute it. This is you can do it by using these palettes or at the top of the screen, but the most straightforward way is to use the shortcut Shift plus Enter, which just repeats the expression for now. And this is because it works with A and B as generic symbols, which have no meaning now, so it cannot do anything interesting with them. But if I, for example, want A to store the numerical value of integer 2, I can execute this line. So from now onward, A is 2. It is the same thing, but I can store in A, which only a few lines ago was just a generic symbol over here. So I store there a number, but I can in the same variable store basically anything. For example, this black disk. So now A is this black disk, and so this is connected to the last point of the text, that Mathematica is strongly typed, or actually now I was showing that Mathematica is dynamically typed, because you can change type of a variable at any time. That it is strongly typed means that Mathematica will complain when you try to do something illegal. For example, if you try to make graphics out of a number which is not a graphic, so it will not try to do it somehow, but it will complain that you are doing something wrong. It will give you this big red square. It is a scripting language. Mathematica is a very high level language, which means that its commands are quite advanced, but do a lot of things you might not be able to influence like straightforwardly. So this can have this is quite useful if you want to do something quickly, but if you want to have greater control, you might need to do more work in Mathematica than in other languages. Of course, I forgot to encourage you to post any questions if you have them throughout the whole presentation. I will try to answer them at the earliest convenience when it will make sense. So now we have seen that Mathematica uses symbols as the important, or this is like the symbolic computation is the important thing of Mathematica, and so we would like to I will just here I'm just showing what all can a symbol be. So it can be, for example, here you can see it can be a number, it can be a vector, a matrix, function. It's just somewhat expectable, but it can be also, for example, a plot of a function, geometrical object, any picture, and even a waveform of a sound. You might even be able to hear, I believe. So yeah, that's and there actually are even more things, but this is just like, apart from the sound, the rest is what you will quite often encounter if you do mathematical things with Mathematica. So as you might have, I will go one slide back and just note stress out that, for example, on this line you can see that the A is in black but B is in blue, and so I will go to, next back to the slide before and explain the colors. So if something is blue, it is like an unknown symbol, no information has been attached to it, while when it is black, it has some meaning. If something is red, you are doing something wrong, and if something is green, for those who know something about programming, it's basically a local variable. It means that you cannot basically use it outside of some expression, and I will show you later that it is a very meaningful thing. So now, speaking about what Mathematica can do on its own without you doing anything, this is extremely large amount of things. You can offer or built-in expressions start with uppercase letters. So it is a good practice to write your own functions and variables with lowercase, so you do not interchange them. It offers quite a good auto-suggestion feature, so if you write first few letters of an expression, it will offer you to finish the expression if it already knows it. And there are about 6,000 things Mathematica can do on its own. Everything from adding numbers to showing some quite insane plots, as I will show you later. Here's just a summary of basic operations. The most important thing is that if you leave a space between two symbols, Mathematica will understand that as a multiplication. And also here I show you that Mathematica can do all these operations in a symbolic way without A and B having to have any meaning. Another very important thing which you will encounter often is the 3 types of brackets Mathematica uses, or many languages use them, but Mathematica uses all of them quite evenly. Parentheses has the same meaning as in mathematics, which means it defines priority of operations. Square brackets, these are even more important because into square brackets you put arguments of functions. And curly braces, these are connected to the basic data structure. So if you like want to work with many numbers at once, you put them with separated by comma into braces and work with them. Somehow I will show you later how. Other basic features Mathematica offers is, for example, finding solutions of equations. Here in this cell, I first clear the meaning of a because it remembers it from before, and then I solve this most basic quadratic equation in general way. So you see that in a little bit strange form, but it gives you the correct answer you would expect. Other basic things Mathematica can do quite straightforwardly is integration differentiation. You see that the integration was as expected. This apart from the fact that it doesn't add the integration constant, you need to work with. You just need to remember that. Differentiation exactly as expected. And here I would just once more like to remind that it would be quite hard to do some operations like that in like many other languages, because normally it would be quite hard to explain to computer that what it should do when it should try to solve a quadratic equation, but Mathematica can do it in this very simple manner. Another feature you can use is assessing the last outputs. So basically, if you write underscore and execute it, percent sign and execute it, you will get the last output. So if I attempted to make here a cell which underscore percent sign, and if I make this cell to be evaluatable, which I do for example like this, so the last output is x here, so I should, when executing this, I should get an x, which it does. I'll just delete that. If you want to get the second last output, you can write more percent signs, or you can write percent sign and an integer, and it will go that many steps back. Next to one of my favorite features of Mathematica is generating nice and informative pictures. You can do both two-dimensional plots, as shown in the first picture, and three-dimensional plots as shown in the second picture. Here just a quick few notes that if you want to manipulate the 3D plots, you can just by without holding any key and just dragging it with mouse, you can rotate the thing. You can move it around when you hold shift and try to drag it, and you can zoom in and out if you hold alt and move your mouse either up or down. Another thing Mathematica is good at or can be good at is numerical computations, even though it is virtually what you wanted to avoid in the first place. Mathematica can do it also. So for example, Mathematica has a very good approach to, or very straightforward approach to arbitrary precision computations. So if you, for example, are interested in a value of pi with and you are interested in the first 100 decimals, you just write here this n, which means numeric or numerical value, and when you execute this line, you will get first 100 figures of pi. If you were doing anything with numerics in Mathematica, it is good to remember that if you want to write 2 as an integer, you write it like this, but if you want to write it as a float, floating point number, you need to write it like this. Yeah, sometimes you don't want to see output of some code, and you just want to do it. For example, if you assign a value to some variable, you don't need to know that Mathematica did that because you know that you just executed the line. So you can use a semicolon for that. So here is, for example, some text, and if I execute it, you will see that you will just once more see the text because it is everything Mathematica can do with that. But if I put a semicolon after it, you will see that nothing appears because the output is suppressed. Okay, so when you know these basic operations, you might want to do them for many numbers at once. And for this, Mathematica employs the data structure called list, which virtually is just ordered sequence or ordered set of the elements. So here is, in the first line, there is a list of 3 numbers, 1, 2, and 3. You could define it also in this way. It would be completely equivalent. Interesting things that the lists in Mathematica can be non-homogeneous, which means that each element of the list can be of a different type. So, for example, this list, it might take a few moments to load the picture. So this list is on the first element of the list is an integer, the second is an unknown variable, the third is a function, and the fourth is a picture, and it can just combine them and you can work with this as it is. One of the more common forms of lists is just a set of numbers. The easiest way to generate such a list is by using this command, because the range 10 command just produces all numbers from 1 to 10, or integers from 1 to 10. This is useful for in multiple occasions. I will start with showing you how to slice the list, which means how to take specific elements of the list. You always need, if you are slicing, you always need to use double parentheses. And so if I want to just, and also on this line, remember that I assigned to the A this list. So this list is now in A. And so if I want to get the first element of the list, I will do this. If I want to get all the elements from the first to the third, this is how I write it. I use double semicolon. And Mathematica supports even this syntax, which means that I want every element from the first to the fifth with a step of 2. So I want every other. So from 1 to 5 it will be 1, 3, and 5. And this is what I get. If you have any previous experience with basically any programming language, you have probably been using lots of for loops, while loops, do, until, and I don't know what else loops. So Mathematica supports them, there is a command for it, but if you are using it, you are most likely using Mathematica wrong. You basically never need to use that. And it is good and bad it can be viewed as good or bad. The good thing is that you have many interesting and specialized functions which can somehow do what normally a for loop does, but these functions can do it better. On the other hand, you need to look for these functions a little bit, but I've most often find it quite useful and easy to approach. So, for example, if you want to get the squares of the numbers from 1 to 10, you just use this simple command, which will generate a list on whose whose elements are squares of the index number, and the index goes from 1 to 10. So executing it will give the square of the first 10 integers. Or you can do, and this is like a very big strength of Mathematica, because it can do it in very interesting and various ways, is Elementwise application of functions. So for example, here without further comment, I just define a function which from a number returns a square. Here I remind you that this command gives the numbers from 1 to 10, and so if I use this command, which virtually says that use the function f of every element of the range 10, it will once more give the squares. And obviously this might look not that efficient, and you might be able to think of more straightforward ways to do this, but you need to remember that you can use any function here, not just this simple squaring function. So let's get forward, because the lists are strongly or closely related to vectors and matrices. So in this 3-line cell, what I do is first I just once more clear the meaning of A, and then you see that I have a variable called vector, on whose right hand side I have a list. So but when you think about it, these two things are basically the same thing, because list is a ordered sequence of elements, and vector is also ordered sequence of elements, so it makes sense to assign it like that. And to also, you see that I don't want to see Mathematica doing that. I want to actually give me on the next line I want to make the list look more like a vector. So this is basically just like formatting the output to look better. But this looks like a very nice vector. And what could you do with a vector? The most straightforward operation is to do a dot product, or scalar product, which you use to measure the size, or or the square root of dot product vector with itself is its length. So if you would do a scalar product of a, b, and c with itself, you would expect a squared plus b squared plus c squared, which is exactly what you get. Here I define matrix. On the right hand side you see a list which has 3 elements, and each is a list of its own. So it makes sense to just like this list of lists interpret as a matrix. And if I put it into the matrix form so it looks nice, you see that it is what we would expect if you would put this in the first line, this in the second line, and this in the third line. Matrices and vectors are nice, but you might want to do some operations with them. So let's see what the product of this matrix with the vector looks like. I would just like to know that the product is simply done by putting a dot between them. And if you think about it, it is what you should expect, that the result is a vector with elements ax, by, and cz. I would just like also to remind that if there is nothing in between those two elements, it means they are multiplied. Another very common operation is to compute a determinant. If you think about it and remember how it should be computed for this matrix, you will certainly realize that it is quite easy and should be the product of x, y, and z. And Mathematica thinks the same. I'm not sure if you have encountered it, but you can do many quite more advanced computations with matrices and vectors in Mathematica, like finding eigenvalues and some decompositions, finding inverses of matrices, and so on. Mathematica can do it all. But we don't have that much time, so I will just move forward. Interesting thing about lists is that you can do element-wise operations. For example, if you remember from the last slide that vector was a, b, and c, and I want to add 1 to each of the elements, I do it just like this. So you see that you get 1 plus a, 1 plus b, and 1 plus c. I can do the same with subtraction, division, multiplication. And you can, because I said that lists can be non-homogeneous, so here you have a list which contains a sound and a plot, and you can just like add 1 to each of the elements. Mathematica will have no problem with that. It is questionable what this means, but you will certainly find this is like to show that Mathematica can do it, and I will leave up to you to think of some maybe a little bit more useful, meaningful way to exploit that. You will certainly have no problems. Another interesting feature of Mathematica you might use quite often is fitting. So suppose here that so let's look at the command. So here is a list of 2 lists. This is the first one, and this is the second one. And so, and each of the like smaller lists has 2 values. And if you just think of the first one as an x value and the other one as y value, it is a point in xy plane. So you have 2 points here. And the fitting function, you give the fitting function some functions, and it will try to combine them in such a way that they are that the resulting function goes through these points. So if you have 2 points, the easiest way to join them is by line. So this is exactly what we define here. We give the fit function 2 functions. One, which represents the constant. Mathematica will try to add the 1 that many times, so the resulting function will be the closest to those points given. And it will do the same with x. So it will do, for example, a times 1 plus b times x, and tries to find the a and b. So the function corresponds to the points in the best way. If you would compute it, you will certainly agree that the correct result is 2x minus 1. let's get now from numbers to pictures. Mathematica supports quite a few predefined primitive graphics. For example, a point, line, circle, disk, polygon. From the little bit more advanced, for example, an arrow, and there are quite a few others. And obviously, one by one, they are not that interesting, but you can combine them into a little bit more interesting things if you want to. Another type of pictures you will encounter quite often using Mathematica is plots. You can have various types of plots. So let's start with, if you write just plot, it means two-dimensional plot. So you see that we are plotting tangents of x, and here you see a list of 3 elements. First is the variable, and then is the lower and upper bound along the x-axis on which we plot. You also can notice that the x here and here, has this greenish tint to it, which is what I was talking about earlier, that it is like you cannot basically from the outside, you basically cannot access this x and redefine it or use it for anything. And it's meaningful because you need to leave this x untouched, so this plot function can do it with its own thing. And this is what you get and what one expects. You can do 3-dimensional plots. For example, here I have product of absolute value of x and y. You see that it is what you might expect, that it is somehow bent along the x and y axis. Here you can take a short. Okay, I was first explain what it does, and then you can take a guess what it will look like. So this is a point in xy plane. You might have seen this is its x coordinate, this is its y coordinate, and those coordinates are parameterized by this parameter. And here you set the range for the parameter. And I will give you 10 seconds to think about it, what it will look like. And so if you were thinking of a half circle, you would be correct. Here is a contour plot. So it is quite closely related to the 3D plot. In that like in the 3D plot you have 2 axes along which you take values, is the x and y, and along the z-axis you put a point basically that high, what is the value of this function, and I hope it makes sense. And in contour plot, what you do is that you show the value of the function not by its height in the z along the z-axis, but by its color. So you see that along the x and y axis, it is the darkest, so it means the smallest value, and it grows larger towards the corners. You can also plot, for example, a region. Here you have a region where x squared is greater or equal to y, and this quite reasonably gives you a parabol. Just to note, Mathematica also supports quite nice network visualizations. And now I will start to getting to the little bit more advanced features, but I think at least this one is worth commenting. So what you are working with and what I am working with now, what you see is the notebook, while there is the second integral part to Mathematica, and it is the kernel, which does the computations. So notebook is basically well formatted set of commands basically a text file, while kernel is like it is basically a program of its own, which does the computations, which delegates them to the CPU and works with RAM and remembers all the results you've computed to some extent, and all the variables you use. Here it is, one nice feature is the parallel computation, that you if you have more multi-core CPU, which is probably standard these days, like at 100% of cases, so you can launch one CPU on each of your cores, and then you can make some computations quicker. It doesn't work every time, but in general you can, at least working with big data sets, you can quite often use this to speed up the computation quite a bit, and use your CPU to its full potential. On the other hand, you sometimes might want to Mathematica to forget something or forget everything. If you want to forget something about only a specific symbol, you, as I have already done, can use the clear command. If you want to clear everything, you can either do this. I will not explain how it works, but you can just like copy this into your notebook and execute it. Or you can just quit the kernel and Mathematica will forget everything. To do this, you go to the top of the screen into this evaluation palette. You go to the bottom of this list, and here's quit kernel, and you just click on it. I will not do it now, it wouldn't hurt it, but I will do it now. But you just quit the kernel, and then you will note that everything is like a dark blue color, which means that Mathematica has no kernel currently available. But it will start a new one anytime you try to execute a command, or you can just go here and start it manually here. And while this might sound, for those who know something about programming, this might sound quite cruel. It is actually quite a common practice to do with Mathematica, so you don't need to worry that you will cause some damage with this. Just few other notes about, for example, if statements is what one surely would expect a programming language to offer. So here it is with quite straightforward syntax. It is interesting that you can give here this other option, which means that Mathematica will do something even if the condition doesn't evaluate to true or false. Interesting. Another thing is, or like another potentially quite strong feature is this simplify and full simplify. For example, it can be quite hard to let the computer know that this expression of sine A cosine B plus sine B cosine A can be somehow simplified in other programming languages, but in Mathematica it is pretty straightforward. As you might expect, it will go straight to the conclusion that it is sine of A plus B. What you certainly will use is, or might want to use, is importing and exporting. For these, there are these two commands. I don't think that the format option is necessary always. Mostly you need the path, and exporting you need to say what you want to export. About exporting and importing into also, the Mathematica employs its own data format, which is called which has which is abbreviated .mx or has the suffix .mx. So if you want to just like take some data out of the Mathematica and use them later on once more, you should export them in this format. There is one feature, one thing I don't like much is that Mathematica search has a default path to search, like to export and import files somewhere here, which is like in your documents on your system disk or system volume, which is not what you might want it to actually do. So here is quite a useful command which sets the directory Mathematica looks for data, or where Mathematica looks for data. It sets the directory to be where the where your notebook actually is right now, where's the file from which you are executing the commands. It is to note that you need to include these two these square brackets after this command, because otherwise it will interpret it just as the name of the command and not it will not evaluate it to the actual path you want to use. Okay, I will skip this one. It is actually pretty interesting how it works, but I will leave it to your own because it would take me quite a lot of time. But on the other hand, I certainly recommend going through this and thinking about what it does and how you could use it, because at least for me it is one of the most powerful features Mathematica offers. Yeah, this is awesome, that important. You can have a look into that, what it does, and think about why it does that. This I will comment on this, how to make functions. So there are multiple ways to define a function. One is to use the expression function, where you first put the variable and then what the function should be actually like. Here I have basically done just define just a nickname for sine of x. On the second or on this line, you can just like assign to the symbol f2 that if it is given with if it is executed with one parameter, it will execute it as cosine of x. So effectively it is the same as using the function, but it does something a little bit different. If you are interested, you can look into what exactly. And one more way to define a function is using a pure function, where you put these hashtags on where you want the variables or the arguments to go later. You can give them numbers. For example, if I wanted to make sure that there goes the first, I would just put there the 1, so it would be the first argument, and if I would wanted to put there the second, I would just write it 2. So I will also execute this one, and now just to see that it works, if I plug pi into f1, I would expect a 0. The same for f3, because tangents of pi should also be 0. And if I plug pi into cosine, I should get -1. So we will see if this list of the 3 functions called with specific arguments will give us what we expect. Yes, it does. Here's like my favorite part of beautiful pictures Mathematica can provide. In the first one, you see some complex plane plot, which is pretty colorful because it basically there are like the color has 2 variables. Its shade and its depth. or intensity, let's say, and these correspond to the phase and magnitude of complex numbers. So this is the first picture. The second picture, you see there quite nice dipole field. In the third one, you see well-known Mandelbrot set. The fourth and fifth are some vector fields in 2 and 3 dimensions. You can rotate this. Have a look at the outward vector field. This last one was for me basically the most interesting, because I found about this feature only when I was working on this presentation. You can have anatomical, if you're interested in anatomy, you can have like the perfect model or high quality models of the human bones, for example, and I think there are also muscles and everything. And even it gives you the tooltips with the names of the bones. So Mathematica can be also very useful as a for studying anatomics if you are a doctor or studying to be a doctor. Yep. So if you find yourself lost at any point using Mathematica, the important question is where you get help. So there are basically two possibilities. Most straightforward is to denote or to highlight what you are what you do not understand. For example, this word, if I would understand, if it was an expression I didn't know how to use it, and press F1, or you can press F1 at any time and it will open documentation. The documentation of Mathematica is one of the best I have ever seen. It will show you a lot of examples. It will explain every single option you can give to the functions very thoroughly. So use it as every time you are not sure how something works. Especially if you are not sure about specific function. If you want to do something more complicated, then you might need to go to the internet. Because it is quite likely that whatever is your problem, someone already had it before. So you can just try to Google your issue, and it will most probably send you straight to the Stack Exchange fora, where just search for your answer. It is like 99.99% likely to be there, if you are not asking for anything completely crazy. So this is everything from me. Thank you for your attention. I hope you enjoyed this whole week, this competition and the presentations. And before you run away, I just wanted to ask you, because I was showing only the simple things Mathematica can do, so I just wanted to ask you, show you something more advanced, and hopefully this will run in few moments, and you can see that if you feel up to, hopefully, oh no, I'm not sure how to show you the current screen. Okay, so just when you return to this presentation, or if you ever return to this presentation, just run this last cell. It runs Minecraft. It is a very simplified version of Minecraft. It is not like full-blown 1.18 or what is the last update, but it runs simplified version of Minecraft, which I find quite astonishing someone has achieved in Mathematica. So now, if I manage to close it, yep. Once more, thank you for your attention, and I hope you will take part in this competition also in the next year.